Hey everybody, today we're going to work on Polygons 4, which might be one of the shortest note sheets of the year. Don't let all the lines fool you. We probably won't be using them all. I just wanted to make sure there was room to go over things. This is more or less just a review of everything that you did from Polygons 2 and 3. We're talking about parallelograms. And the big idea here is you should be able to look at a picture and be able to tell if there is enough evidence to prove that something is a parallelogram or not. So if any of the 5 statements that we are about to do are true, then the polygon that you're looking at is a parallelogram. Okay, so rule number 1, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Now, that was one of the rules we learned right off the bat. In a parallelogram, both pairs of opposite sides are congruent. So that is not new, not much of a surprise, but it is something we need to remember. All right, now I'm going to keep going. If at any point you need more time to write, just stop the video. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then you have a parallelogram. Now you're going to see pictures of this here in a second. We're actually going to do a few bonus problems on the back because the video is going to be so short. So you'll see what I'm talking about here in just a little bit. All right, rule number 3. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. Once again, that's another rule that you've done in the past. Okay. Rule number 4, if the diagonals of a quadrilateral bisect each other, okay, so that's rule number 4, and you knew that too. This is all basically what we talked about in Polygons 2. We're just trying to review it and put it all in one place. Everything from Polygons 2 and 3. And we're sort of working backwards. This is actually sort of the converse of what we talked about before. Last but not least in this section, if one pair of opposite sides of a quadrilateral, this one's new, are both congruent and parallel. So that one's a new one. We're going to bring that up here in just a minute when we see our pictures from the back. So essentially, if you get a parallelogram and one of the pairs is both parallel and congruent, so you're going to look and you're going to see 2 symbols. You're going to see the congruent symbol and you're going to see the arrows. That means it is a parallelogram. Okay, now, in Polygons 3, we talked about a couple of specific types of parallelograms. We talked about a rhombus and a rectangle. So let's get into those really quick. We talked about these. One of the things we look for in a rhombus is the diagonals. If the diagonals of a parallelogram are perpendicular, it is a rhombus. We drew quite a few pictures of that when we did Polygons 3, so if you're not sure exactly what that looks like, then you can just look back at it. Also, if one diagonal of a parallelogram bisects a pair of opposite angles. Remember, in a rhombus, every diagonal also behaves as an angle bisector. It's important to remember that. Based on the pictures, you should be able to get a sense when you're going through. And again, you're going to see some pictures here of some parallelograms in just a second, and I'll show you what I'm talking about. Last but not least, we talked about a rectangle. And in a rectangle, you should be able to know, remember a rectangle has 4 right angles, but one of the ways we were able to check is that if the diagonals of a parallelogram are congruent, then that means it is a rectangle. All right, now, what I want to do here is make sure we get sort of a little Venn diagram effect. I want to show you exactly what I'm talking about here. So I'm going to do sort of a cheesy Venn diagram, but I'm also going to do it with our figures. So we have a parallelogram right here. One type of parallelogram is a rhombus. Okay. We also have another type of parallelogram, a specific type, and this one, and there's going to be some overlap, so I'm just going to get rid of it right here. There you go. This right here would be a rectangle. And then there is one very specific type of figure that is both a rhombus and a rectangle. It sort of fits both requirements. We didn't talk about it today, but we talked about it previously. If something is both a rhombus and a rectangle, so that's sort of that little overlapping part right there, then that means it is a square. So if something is both a rhombus and a rectangle, it is a square. Now what I was trying to do there, it was kind of cheesy, but I don't know if you have seen sort of the Venn diagram effect here when you have two categories and then meeting in the middle. The square is sort of that meeting in the middle. So you have a rhombus on one end, you have a rectangle on the other end, and the place in the middle where they meet would be the square. So that's sort of the diagram that I was going for. Hopefully that made a little bit of sense. All right, now, real quick, the last thing I want to do, if you look on the back of the paper, it says, are you given enough information to determine whether the quadrilateral is a parallelogram? Normally, we don't really have enough time to go through all the back, but I think it would be helpful to at least get through this first section. So as we go through here, I want you to think about all the rules that we did before. So one of the rules that we did, it was actually the last one. This was sort of the new one. Remember, if one pair of opposite sides is both parallel and congruent, we had that rule. That was actually, if you scroll up here, that was rule number 5. So what that means is, sure enough, we got a big old yes. That picture does represent a parallelogram. All right, we have picture number 2 here. And we've got this and this. That means they are bisected. They're broken down into 2 equal pieces. And then same thing here and here. So the diagonals bisected each other. So once again, we've got absolutely yes. And you could say the diagonals bisect each other. We can just cut to the chase there. All right, we look at number 3. And once again, number 3, that's going to be a big ol' yes. The reason is if the opposite sides are congruent, then that means it is a parallelogram. So 1, 2, and 3, it said, do you have enough information? Yes, absolutely we do. Now number 4 is going to get a little bit weird because we have one pair of sides that are parallel, and then we have one pair of sides that are congruent. But that doesn't necessarily mean anything. I mean, yeah, it says this is 12, but what if it was 12 going the other way? Then would it be a parallelogram? No, at that point, it could be a trapezoid. So that is not enough information. And when it says explain, you could just say it could be a trapezoid. That would be fine with me. All right. Number 5, this is actually going back in time. If we have alternate interior angles that are congruent, that means you have parallel lines. And if you look in this picture, what we actually have here is 2 pairs of alternate interior angles, which means we actually have 2 pairs of parallel lines. Which means, according to our rules, I mean, that's the actual definition of a parallelogram. If you have two pairs of parallel sides, then that means it checks out. All right, last but not least, I want you to focus on this angle right here. It is 120. We had one last rule. I'm going to scroll up here. If we have one angle that is supplementary to both of its consecutive angles, then that means it's a parallelogram. 120 plus 60 is 180. And if we go the other way, 120 plus 60 is 180. So, sure enough, we ended up going 5 out of 6 in this section. 5 out of the 6 happen to be parallelograms. And the reason is one angle is supplementary to both of its consecutive angles. So it checked out. We went both ways, we tested it, and it worked. All right, I hope this helps. I'll see you next time.